So, as my earlier classes student, I am telling you that liquid exert pressure, and many examples I have given that liquid exert pressure. And you have also demonstrated many activities. Now, one summary of the characteristic of pressure in liquid. See, pressure increase with the depth, that is clearly. Pressure acts in all direction. All direction means if in a container there is the liquid, then this liquid exert the pressure in all the direction of the container. That is the simple meaning, that pressure exert in all the direction. And pressure at 2 points at the same level is same. Liquid are equal. That is also one point to be noticed. Suppose this one is a container, and in this container there is a liquid, suppose water. So if you taken the 2 point in this container, one this A and another point B at the same level. Now listen to me carefully, that level would be same, then the pressure would be equal. Why? Because the liquid is similar, means there is no changing of the density. Another one, the height would be similar. How height is similar? Are you seeing that B point and A point height is similar? So depth of the column is similar also. Depth of the water column is also be similar, and that's why the pressure would be equal. Another concept related to the pressure exerted by the liquid. Another concept, that is pressure does not depends on area of surface. Pressure exerted by the liquid do not depends on the area of surface, like in case of solid. Whereas you have seen in the solid, pressure depends on the surface of contact area. Here another thing is, pressure does not depends on the shape or size of container. In which container you kept the liquid, it exert the pressure at the same extent. So pressure exerted by the liquid do not depends on the shape or of the container. Now see the next application of the pressure in liquid. In many the pressure of the liquid, the wall of a dam is much thicker at the bottom than at the top. That is the reason, because when you go the deeper, then the pressure would be more. When we go the deeper inside the water body, then the depth of the water column be increases, and as we know that when the depth of the pressure exerted by the liquid is directly proportional to the depth of the water column. So here you are seeing that wall of the dam is thicker, going to be thicker from upside to downside. Why? Because when you will go downwards in the water reservoir or in the sea, then the pressure will be increases, because the depth of the water column be increases. Same as you this also you can compare when sea divers go through the bottom of the sea, then what about the pressure? Simply the pressure will be increases. Why? Because when the sea divers go at the bottom of the sea, then the water column depth be increases, and as we know the relation that P is directly proportional to the H, depth of the water column. So when the water column or the liquid column depth be increases, then the pressure also be increases. Here this concept, this dam wall is going to be thicker when you go downwards, because it must withstand the increased lateral pressure. So that it can withstand the increased lateral pressure, in depth of water. Why? Because higher the depth, higher the pressure. So the thicker the ball. This is clear cut concept. So here we use the pressure application in construction of dam. In the next thing, application of pressure in thick wall built in submarine. If you see the submarine, thick wall. Why the thick wall built in submarine? Because the deeper the submarine submerged into the water, greater the pressure. So to overcome the pressure, the submarine wall built very thick. Submarine is built with thick walls so as to withstand enormous pressure at greater depth. Because we are knowing, and that is the reason that the sea divers wear a special suit when they go in the deeper in sea to withstand the pressure. Otherwise, their body becomes just pinch by the liquid pressure. Because when you go downwards in the sea, then liquid pressure continuously increases. So that all are the reasons. So here also in the submarine wall formation, we can give the reason of the pressure increase with the depth. And see the blood transfusion. How in the blood transfusion the bottle is hung at higher position to increase the pressure of liquid. Understand it? Because the pressure to go the liquid inside our body, inside our blood, the pressure of the liquid must be higher than our blood pressure. Otherwise, that liquid cannot be go inside the body. So to increase the pressure, we hang this bottle at a higher position to increase the pressure. So it has sufficient pressure to flow into the veins of the patient, and it can just easily go into our veins, just opposing the blood pressure. So, or we can call this pressure must be greater than our blood pressure. For that, we hung it at a higher position. Here also, there is an application of the liquid pressure. Next thing, now we will discuss about the pressure of gases, or the pressure of gases phases and atmospheric pressure. Because in our atmosphere, there is the mixture of gases, and our atmosphere also exert the pressure on each and every object on us. How? Let's see. Air inside the balloon are in random motion which collide all over inner surface of the wall and exert the pressure. Forces of the collision pushes the ball of the balloon and exert the pressure of the balloon ball. So, after filling the air into the balloon, inflation of the balloon shows that air also exert the pressure, or the gaseous form of the material also exert the pressure. Next thing, gas pressure is the force per unit area. If you see the gas pressure is the force per unit area, and by the gas molecules, they collide with the walls and create a pressure on the walls like that. This one. These are the molecules which collide with the wall of the container and exert the pressure. Gas molecules are always colliding with the wall of container and produce force. The force will act on the area of the wall of container and produce pressure. Because earlier I told you that force exert the pressure, and then finally pressure proceed the motion. So here is also the force of the molecules that exert the pressure on the internal wall of the container. Now see, what about the atmospheric pressure? Atmospheric, what is atmosphere, student? So one thing you should know, atmosphere is a thick layer of air surrounds the earth, And we know very well that air has the mass and weight. Why? Because in 6th class you have studied that air is a mixture of different gases, and different gases has their molecules, and the weight of the atmosphere acts on the surface of the object present in the atmosphere and produce the pressure. That pressure is said to be the atmospheric pressure. So the atmosphere around us also exert a pressure on each and every object present on the Earth's surface. That pressure which is exerting by our surrounding atmosphere is said to be the atmospheric pressure. And let's see how the atmospheric pressure varies, or what are the factors on which the atmospheric pressure depend. Let's see. Atmospheric pressure varies with the height of the object above the sea level. At higher altitude, the temperature and density of the air are lower. As a result, the frequency of the collision of the molecules is lower. As a result, the atmospheric pressure is lower. It means when we go upwards from the sea level, then the pressure will be decreases. Okay? Why? Because the density of the air decreases, because the temperature of the air decreases. So the kinetic energy of the molecules also be decreases, and collapsion also be decreases, and that is the result of decrease in the pressure. And atmospheric pressure also acts in all direction. Atmospheric pressure, like the liquid pressure, atmospheric pressure also exert in all the directions. So student, basically atmospheric pressure depends on the altitude. When you go upwards from the Earth's surface, then pressure would be low, and that is the reason that the ball pen or ink pen leaked just in the upper altitude or higher altitude in atmosphere or in aeroplane. Why? Because the internal pressure of the pen becomes higher than the external atmospheric pressure, and that's why inks comes from the higher pressure to lower pressure, means from inside to outside. So the pen ink be leaked at higher altitude. Another thing is, at higher altitude our body becomes burst if we go at higher altitude without any suitable suit which maintain the pressure. Why? Because at Earth's surface we are not feeling the pressure. Why we are not feeling the pressure? Suppose that is our body. So our body also exert a pressure from inside to outside. That is the body pressure. Why? Because our body has many liquids, especially blood and lymph, and so many liquids are there, and we know that the liquid exert the pressure. So that liquid is exerting the pressure from inside to outside, and this pressure is equal in normal conditions in which we are living. This pressure is equal to the external pressure exerting by the atmosphere. That is the atmospheric pressure. And internal pressure, that is you can call body pressure. So in the normal condition, why we are not feeling the atmospheric pressure? Because in that condition our body pressure is equal to the atmospheric pressure, and that's why we are not feeling the body pressure, not feeling the atmospheric pressure. Generally anybody can say that we are on the Earth's surface, and why we are not feeling the pressure of the atmosphere? So that is the reason. Why? Because, my dear student, our body also exerting the same pressure, and this pressure is just equal to the atmospheric pressure, and in that case body pressure is equal to the atmospheric pressure. Now you can easily, means when we go upwards, then our body pressure increases than the atmospheric pressure, because body pressure increase remains constant and atmospheric pressure decreases. So situation is like that, and that's why our veins becomes burst. You know, earlier I missed. So earlier the equation is for the lower altitude where the pressure is very low. Understand? So in this case, our body becomes worst when we go upwards, and that's why the skydivers wears the special suits to maintain the pressure. Means we have to maintain this condition. Body pressure is equal to the atmospheric pressure. Then we can normally overcome the situation of low and high pressure. Is that clear? Now see atmospheric pressure, how the atmospheric pressure varies at height. Atmospheric pressure, the pressure in the space around satellite is almost zero. Space around satellite is almost zero. At 5,600 meter above sea level, the atmospheric pressure is about 50,000 Pascal roundabout, or 10 to the power 4 Pascal. And an aircraft traveling at an altitude of 11,000 meter will experience an atmospheric pressure of 25,000 Pascal. So my dear student, this is the variation of atmospheric pressure with the altitude. So especially we can call finally the air pressure depends on the altitude. So this activity you can do. You can demonstrate activity to show existence of atmospheric pressure. How? The water remains in the glass. This is due to the atmospheric pressure acts on the cardboard, pushing it up. So see, one activity you are seeing, take some cardboard, covered the glass, covered the water filled glass by a cardboard and just hung it, invert it. Then you will see the cardboard pushing. Then cardboard remains pushed it up due to the atmospheric pressure acts on it from the lower side. So do that activity, and with that activity we will meet another activities also. When you drink any liquid, any beverage, then you sucked air inside the straw, that removed leaving a low pressure area, and that higher atmospheric pressure acts on the surface of water and push drink into the straw. That is the simple reason. Sucker hook is also, when the sucker hook is pressed and air inside the is forced out and leaving a low pressure area, then the high external atmospheric pressure on the sucker press down on the hook and makes it sticky firmly to the ball. So that are the examples, that are the activities which you can do. In the vacuum cleaner also, a low pressure area, and that the fan suck out the air when it is switched on, and the space in X becomes partially vacuum, so dust particles are trapped, but the air still can flow through the exit. So the higher atmospheric pressure forces the air and dust particles into the dust bag. Simply, that is also the higher and lower pressure of the gas event. So these are the different experiment in which you are seeing the applications of the air pressure. Those student, try to do some activities, then after that we will meet by other different applications of the air pressure. So that is about the air pressure. Thank you. Have a nice day.